Hello, students. I am recording this video to explain what the linearization of the data is, right? So during this class of Physics 2 with calculus and, the lab component or the lab class, we're going to be working with data, of course. This data will be usually collected in a video. So we're going to be sharing with you usually a video where the experiment is explained and where the data is collected. I will be doing another video later explaining that. And once you have the data, you're going to have to process that data and to interpret what the meaning of the data is. So what this data represents, what information we can extract from this data, right? And how we can use that information in order to calculate experimentally some physical quantities. So this was the example that you had to use for the first lab. The first lab was basically about linearization. So it was just to try to show you how to do the linearization of the data. The example was Torricelli law says that for a tall column of liquid in a container with a small hole at the bottom, the water will flow out the hole with a velocity v, which is equal to the square root of 2EH. In lab, students measure v, the velocity of the water, and h, the height of the liquid column. If the graph of v versus a square root of h in this graph, that would be a linear graph with a slope, a square root of 2g, and with an intercept of 0. So they say use the following data to plot a linear graph and to use the slope to calculate an experimental value for g, determine the percent of error, using that the theoretical value of the gravity, the acceleration of gravity, is 9.81 meters per second square. So they give us here the data table. The data table contains two columns. In the first column, we have the height of the column of liquid. In the second column, we have the speed of the liquid, in this case, the water, when flow out of the hole, right? What are we supposed to do? We're supposed to graph this, making a linearization, find the slope of the line. Then we know from the slope how to calculate the experimental value. And later we're going to compare the experimental value with the theoretical value. So we're going to find the percent of error between this experimental value and the theoretical value, right? So that's basically what we are required to do in this experiment. Now, what I want to emphasize here, the speed is given in meters per second. The height is given in centimeters. My recommendation is this. The acceleration of gravity, the units of acceleration of gravity are meters per square second. So acceleration of gravity is in meters per square second. The speed, the values of speed are given in meters per second, and they give us the height in centimeters. I will recommend you to convert those centimeters into meters so we can work, with, in this case, units, right, that are all similar, okay? So the first that I would recommend you to do is to do the conversion of these centimeters into meters. You know that 100 centimeters is equal to 1 meter. So would be basically to divide these numbers by 100. So that was what I did over here in this table. So I just divide by 100. And then I found that now my height is in meters, right? And the speed is just the original values given in the table in meters per second. Now, what are we going to really graph? We're going to be graphing the square root of the height versus the speed, right? Now, something important here. The speed will be, in this equation, b equals the square root of 2g h. The speed will be equivalent to what is y, you know, when we have data in x comma y. When we have just those mathematical functions that you learn in college algebra, where you have y equals 3x plus, you know, in that y was the dependent variable and x was the independent variable. It's exactly what we have here. B will be like y, the speed will be like y, so the speed will be the dependent variable, and the square root of h will be the independent variable, or will be like x. So in your graph, you will be graphing in the x-axis the square root of h, in the y-axis b. What happens is you graph square root of h in the y-axis and b in the x-axis? The graph is gonna change. You know, the slope is going to be different, and the equivalency between the slope and the acceleration of gravity is gonna change. When you graph the speed in the y-axis and the square root of h in the x-axis, is when you have that the slope is equal to the square root of 2g. But if you graph square root of h in the y-axis and b in the x-axis, then this expression you have here that said a slope equals square root of 2g is not valid anymore, right? So you must be very clear of that. So what I did, I just add one more column here, that is this second column, where I found the square root of h. So as you see, what I did using Microsoft Excel was to say, okay, find me in this column the SQRT C2, because in C2, in the cell C2, I had the first value of the height. So find me the square root of h, you know, for the first value of h. And like that, I did it for all the other values of h. So I found the square root. So what I will be graphing, really, I will be graphing the square root of h and the speed. Now, this is the graph that I got when I graph square root of h in the x-axis and b the y-axis. But I will delete this graph and I will show you how I did it. So I will delete the graph. Sorry, give me a second. I would like to delete this, the whole thing. And then I'm gonna just create the graph. So what is a super common mistake? To select line graph. That is wrong. Why? Because the line graph are not used, you know, to graph or to compare two variables. When these line graphs are used, this type of chart is used to show trends over time. That means over years, months, days, or other categories. You know, this is when the order of categories is important, when there are many data points. Well, this is not the type of graph that we use when we want to compare two variables, when we want to find the relationship between two variables, when we want to get a regression equation. This is not the graph that we use. So don't select line graph. You will select the scatter plot graph. You will select the scatter plot graph, right? So I will say insert, and I will insert one scatter plot graph. Once I have my scatter plot graph here, I will make a right click and we say select data. I will click on that. Okay. I can just put the series name here. So we say this is graph of SQRT of H versus B. What is gonna be my x-axis? In the x-axis, I will have the square root of H, right? That would be my independent variable. So I just click on series X values. I select all these values. And then now I will select the Y values. So you have to clear this cell and you say, what are my Y values? My Y values are the values of a speed. So we just go and pick all these values. And this is the graph that I got. So we say, okay. And I will say, okay, one more time. Now, if you click here, you can add axis titles. So we say what I have in the x-axis. In the x-axis, I have SQRT of H. So the square root of H, right? If you want, you can put the units and you say this is in a square root of meter. That would be the unit. And the axis title, the y-axis, will be a speed. You could include the units if you want also. I can also modify, for example, the, well, you can add data labels. I could modify here these values because as you see, the graph is starting almost at 1 here in the SQRT of H. So I can just make the minimum closer to 1. So I can just modify this minimum here. Say we pick 0.8, like that. The graph is not gonna be, all just skewed to one side. So I will say that that would be now, my scale in the x-axis will start in 0.8. It doesn't change at all the equation, and then now I will say I want to add, let me close this. I want to add a trend line, but I will say, give me all the options. I am trying to get, in this case, the trend line. Why? Because we are making a linearization, so we are supposed to obtain a graph that is aligned, there is a linear relation between the variables. So that's why I will just pick the linear, and then I will set that the intercept will be in 0, 0, and I will say that I want that they display the equation on chart. When they display the equation on chart, this is the equation they give me. 4.4812x. I can just now increase the size of the letter. So I just go here to home and I increase the size of the letter because I want to see the equation. I want to be able to read the equation, right? If you don't set the x-intercept to 0, 0, then this value of slope is going to change a little bit. Now, once you have this, the trend line, which is this dashed line you see here, and that line is the line that better fit all the data points, you can now, in this case, pick this value of a slope. So this number you see here is the slope, right? This is the slope. Well, with this value of a slope is, what we are going to use to calculate or to determine experimentally the acceleration of gravity. right? Because remember, a slope is equal to the square root of 2g. So if I solve for g, the first I have to do is to, of course, here, square both sides. So we get the square of the slope is going to be equals to 2g. So we divide by 2 both sides. So we get that g is equal to the square of the slope over 2, right? That's why I get this formula here that say that g is equal to the square of the slope divided by 2. So what I did, I just put here the value of the square of the slope. Let me correct it now for this new value that I got because I did it the first time, you know, without making the intercept 0,0. So I will change this. And it changed, you know, then now to 10.04, which is going to be lower error. Because what is the value of the, so you know, what happens is you don't set to 0,0 the intercept. If you don't set to 0,0 the intercept, you will get a value here that will be much greater than the value, you know, that really you get if you set the intercept to 0,0. And why we set the intercept to 0,0? Because there is no intercept in this equation. There is no intercept other than 0,0 in this equation. Remember the equation of a line y equals mx plus b, where 0, b is the y-intercept. So you are just saying my y-intercept would be at 0, 0. I will just make later the same modification here, so we'll just see how this slope change. Now, once you have the value of the slope, that was 4.4812, and with that slope, you calculate, you know, the value of the gravity, and you can find now the percentage of error. So how you will find this percent of error? You will say that the percent of error will be the theoretical value, which is 9.81 minus this value, right? Times 100, because I want to get that in percent, divided by the theoretical value that is 9.81. Now, oh, there is something wrong here. Yeah, I was missing a parenthesis. I'm sorry, I was missing a parenthesis here. Let me close this parenthesis. Oh, no, wait. Let me double check. Yeah, the error that I made, you know, is an error with the parentheses. So when you are working in Microsoft Excel, you must be very careful with parentheses, because I'm multiplying by 100, but I have to include 2 more parentheses here. I will just find the difference between 9.81 and the value of gravity that I got. You know, I will multiply that times 100, and then I will divide by 9.81. If I do that, now the error that I got is 2.3, basically. Is minus 2.35 because we have that we overestimate the magnitude of the gravity, right? Okay, so we can express this error and this gravity with 2 decimal places if we want, or with 1 decimal place, right? Because, no, 2 decimal places, because we have the G with 2 decimal places, 9.81. So I can just modify the value here. So we say, let me change this to a number with 2 decimal places. So basically the value of gravity, experimental value of gravity that I found, 0.04 meters per second square. And then this is going to be my error. If I want to get this value positive, I can just use the function absolute value. I can use the function absolute value. And now that gives me this positive and in percentage. I can modify this so it shows just only 2 decimal places if I want. So we round. So I have an error of 2.35%. Now, what happens if you graph? What happens if you graph the speed in the x-axis and the square root of the height in the y-axis? Well, the formula to calculate g will change completely. Why? Because now g will be 1 over 2 times the square of the slope, right? I just invite you to solve for a square root of h in this equation. So you're going to get that square root of h would be equals to 1 over a square root of 2g times b. So that means that the slope would be 1 over 2 times the square root of 2e. So you should now, with this, find your gravity, and then when you solve for the gravity, you will get that the gravity would be 1 over 2 times the square of the slope. I'm going to do something here. Let me just fix in the trend line. The thing about the intercept, I will say that the intercept is going to be 0,0. And when I do it now, let me just show the equation for the new trend line. So the equation for the new trend line would be this one. This new trend line is the trend line that you see here below. Let's see if it let me eliminate this other. No, it didn't. So let me just go back. Well, it didn't let me eliminate the other. So instead of using this equation, I'm going to be using now this other equation. That is where I said that the y-intercept would be a 0,0. So you change, the value of the slope. This one is going to be more accurate, right? This is something you can do easily. As you can see, I will increase the size of the letters to read better, and then now I will go and fix here the value that I use. So the value of the slope is really 0.223. And I use 0.223. I got now my slope equal to 10.0545. What? Meters per second squares. Sorry, this is not the slope. This is the gravity, right? The experimental value of the gravity. The slope is 0.223. So the experimental value of the gravity would be 10.0545 meters per second square. Well, you can do exactly the same that I did over here. To calculate the error, we can just modify this. So it shows only 2 decimal places. So approximately 10.05 meters per second square. So the error will be very, very, very similar, to the value of error that we got here. So again, I will find the percentage of error for you. So how you calculate that percentage of error, you will say that this is basically equals, I will just use the absolute value function, the absolute value of, then I will find the difference between 9.81 minus, this value we have here, right? I will multiply that times 100, right? And sorry, times 100 would be outside the parentheses. Oh, give me a second. So it would be times 100 here. And then I will just divide by 9.81. There is the theoretical value, right? And when I say this, there is something wrong again with the formula. Let me fix it. Yeah, basically I was missing one parenthesis here. So I included parentheses, and then I got that the error is just 2.35%. 49%. So it's a little bit higher, the error in this case. Of course, it's just a little bit higher. You know, the magnitude of the acceleration of gravity is just the difference is in the second digit after the decimal point. So basically, my dear students, you know, this is, you know, what you were required to do in this lab. And this is, you know, what the linearization is just to get a data set that that doesn't have necessarily a linear relation between the variables, right? Because, for example, if you graph just the speed versus age, you don't get a straight line. To get a straight line, you have to graph b versus a square root of age, right? Just graphing a different, or using just only age instead of a square root of age, you don't get a linear graph, right? So linearization is basically that. It's just to get a data set that is not, or where the variables don't have a linear relation, and just by making the right transformation, just, you know, or by selecting, more than making transformation, by selecting the right independent variable, you can make that the graph behave as a linear graph. And then from that, the most important thing is to be able to interpret what is the slope in this case, you know, what the slope represents in this case. So I hope this video helped you understand, you know, first what the linearization is, how to work with the graph, how to process all this, right? So thank you for your attention, and hopefully, you know, this is going to help you in future lab activities.